Liquid water has been found on Mars, and not just in the form of a puny trickle, but as a gigantic underground reservoir that could form a planet-spanning ocean. But how did researchers even get on the trail of the red planet's splashing secret? What does this groundbreaking find mean for future Martian settlers? And above all, could there possibly be life hidden in the Martian water? Mars has been through a lot in the course of its existence. Although the celestial body presents itself today as a cold and bone-dry planet covered all over with rust, it can look back on a wet and happy past. It's now considered certain that until 3 billion years ago, our planetary neighbors still had numerous rivers, lakes, and even some full-fledged oceans. But with the loss of the dense atmosphere, the Martian waters also disappeared. But where did they go? In other words, what happened to the large liquid water deposits that once transformed Mars into a life-friendly world? Well, that is precisely the question that has been driving experts for some time. The data collected during previous research missions suggests that the ice caps at the Martian poles are simply too small to have stored all the water from the former oceans. The water ice deposits that lie dormant under the planet's surface in the mid-latitudes are not large enough to solve this mystery either. As a result, the idea has become established in the astronomical community that the cool wetness left the red planet quite some time ago. Since Mars has no magnetic field, the high-energy solar wind was able to act on its atmosphere unhindered, thereby snatching most of the Martian water into space. Well, so much for the theory. But what if this assumption is simply not true? What if the water of the oceans was not actually dragged into space at all, but is instead still hidden in the depths of the Martian crust? This is precisely the exciting hypothesis that sparked the interest of the research team led by Vashon Wright of the University of California in San Diego. To determine the extent to which this hypothesis matches reality, the experts took a close look at the seismological data collected by the NASA lander InSight on the ground between 2018 and 2022. InSight's measurements had already shown that there is hardly any water in the Martian crust at its location, but only to a depth of around 300 m. However, the researchers now literally looked deeper into the mystery and considered what the situation is like 11.5 to 20 kilometers below the surface in the middle crust of Mars. Generally speaking, the average annual temperature on Mars is a frosty minus 68 degrees Celsius. But in this hidden underground world, it could still be warm enough to allow the existence of water in a permanently liquid form. Earlier evaluations had also shown that the corresponding crustal area could be riddled with rock pores that could offer countless loopholes to the cool liquid. Ultimately, the scientists combined the seismic data with a mathematical model of rock physics, which terrestrial researchers use, for example, to detect oil deposits or groundwater reservoirs. And the bottom line was a groundbreaking result. The analyses confirmed on the one hand that the middle Martian crust is permeated by numerous cavities that make up more than 15% of the rock. And on the other hand, the data indicated that the corresponding crevices, cracks, and pores are actually filled with liquid water. The giant water reservoir on Mars. The research group stated that in terms of their study, a medium-sized Martian crust of fractured magmatic rock saturated with liquid water is the best explanation for the data collected. For the sake of completeness, however, it should be mentioned that this spectacular announcement currently has a small caveat. While it is true that a vast water reservoir could be hidden deep below the Martian surface, this is only true if the research results are representative not only for the InSight location, but also for the rest of the planet. But then the red planet could have a groundwater reservoir in its deep rock pores that even extends across the entire celestial body. And that's something we simply have to keep in mind. While Mars was long considered the quintessential planetary example of a dust-dry desert world, the researchers' calculations now show that the middle crust contains enough water for a global ocean that would flood the entire surface of Mars, covering it 1 to 2 kilometers deep. In the same breath, however, the poor water reservoir could also solve the mystery of the water loss. In this scenario, the planet would not have lost its wet face to space through atmospheric outgassing, but instead would have simply relocated it. According to this, the majority of the former Martian seas could have seeped into the depths of the planet's crust, where it has been preserved to this day in the form of pore water. But now that the astronomical divining rod has failed, a completely different question arises. What does the deep water reservoir mean for future Martian astronauts? After all, it's well known that men like Elon Musk not only dream of being the first to bring a human to Mars in the near future, but also of one day building permanently inhabited stations on our neighboring planet. So, could future Martians simply scoop water out of the underground reservoir? Well, not really. The fact is that there is simply no drilling technology that can reach that far down. But just because we can't get our hands on the Martian water doesn't mean it's not important for research. On the contrary, Michael Manga, a co-author of the study, states that the discovery of water opens a unique window into the climatic past of the red planet. At the same time, however, the hidden water reservoir is also considered a place where life may once have existed, or even still does. The home of extraterrestrial life. There is no question that the hypothetical Martians would be at home in a real extreme world. But there is also no question that we know of a number of terrestrial creatures that feel right at home in just such extreme worlds. For example, there are the sponge-like sessile creatures that were discovered a few years ago under the dense Antarctic ice sheet. These bizarre creatures slumbered a full 900 m below the surface, and they survive in an environment where sunlight and constant food sources are foreign concepts. And while black smokers at the bottom of the deep sea are sometimes even suspected of having paved the way for the development of life on Earth in the first place, the inhabitants of the so-called deep biosphere are also true survivors. The cellar dwellers of the Earth mainly present themselves in the form of bacteria, viruses, and fungi, which not only thrive in the sediments of the oceans, but also in volcanic rock, and even in the kilometer-deep bedrock of the continents. And if the constant darkness and lack of oxygen don't manage to put an end to terrestrial life, why should it be any different on Mars? Well, Michael Manga also wonders about this. And since water is a fundamental prerequisite for the development of life similar to that on Earth, he doesn't know why the underground reservoir of Mars shouldn't also be a life-friendly world. In the same breath, however, Manga emphasizes that there is still no evidence for the existence of Martian life. But at least we now know of a place that would, in principle, allow life on the red planet. Have the traces of Martian life already been found? Well, maybe yes and maybe no, but one thing at a time. The Mars rover Perseverance, which has been in operation since February 2021, has detected a rock about 1 m long and 60 centimeters wide at Jezero crater that is currently making big headlines. That's because the rock is actually adorned with some striking spots that could indeed indicate chemical reactions that microorganisms use as an energy source. Spectrometer evaluations have shown that the spots and their surroundings contain organic carbon compounds. And together with the phosphates and iron that have also been detected, the Martian signatures are reminiscent of the traces often left behind by microbes on Earth. More specifically, such deposits on our home planet are often associated with fossil traces of microbial life that have lived underground. Iron and phosphate, for example, are typically released when these microbes reduce iron oxide. The favorable conditions for rock life to flourish on Mars were probably created by the water that, according to our findings, once flowed over Jezero crater. But does this finally answer what is arguably the oldest question of humanity? Whether Earth is really the only celestial body in the universe to have produced life? Well, not quite. Although the organic molecules on Earth are often the result of bacteria, they can also be formed in a geochemical, abiotic way that does not require the involvement of living things. With this in mind, it is also conceivable that Jezero crater does not show us traces of microbes but merely the result of volcanic activity. To support this, the experts point to a grain of the mineral olivine, which was also found in the rock and is considered a typical component of magma. And so it happens that the Perseverance discovery currently raises even more questions than it answers. And unfortunately, we will also have to be patient for a while longer before the scientists have deciphered the true background of the Martian boulder. This is simply because the Mars rover has reached the end of its analytical capabilities. The researchers have already captured Jezero crater on camera from every conceivable perspective and bombarded it with lasers and X-rays to understand what really led to the formation of the mysterious spots. It's therefore essential to bring the rock sample to Earth and examine it there with high-precision analytical instruments. However, when and how the corresponding Mars sample return mission will be completed is currently still written in the stars, just like the answer to the question of whether Martian microbes were really at work here. And now you're welcome to get down to business and click on the subscribe button. Become part of our community now and never miss an exciting video from our channel Digital Discoveries. We'll see you soon.